All right, let's dive into one of the most incredible stories in engineering, the evolution of the marine engine. We're going to trace the line from a simple kitchen teapot all the way to the absolutely colossal powerhouses that move, well, pretty much everything around our world today. And it really all boils down to this one question. How on earth did that lead to this? Because the answer, you see, it isn't just about gears and pistons. It's about this amazing chain of innovation, one idea leading to the next that literally reshaped our planet and built the modern world. So let's follow that chain.
So our story kicks off way back in the 18th century, and it starts with a guy named James Watt and a really simple, everyday observation that would end up igniting the entire Industrial Revolution.
I mean, think about how simple this is. Watt saw that the force of the steam could lift the teapot lid, but the real breakthrough was realizing it didn't just lift it once, it could do it again and again, up and down in a consistent rhythm. This wasn't just some random puff of hot air, this was a force you could actually harness to do real mechanical work.
And this observation led him straight to the very first big idea in our chain, the external combustion engine. The name sounds complicated, but the concept is actually pretty straightforward. You burn your fuel, like coal, outside the engine itself. You use that fire to heat up a big tank of water, a boiler, right? And the super high pressure steam that creates, you pipe that into the engine to push the piston. Fire on the outside, work on the inside. Now, this wasn't just some clever little gadget. This thing powered an entire era. It was a revolution. But, its greatest strength, that external fire, well, that also turned out to be its greatest weakness.
I mean, don't get me wrong, steam engines were a complete game changer. They gave us powerful ships, massive factories, incredible trains. But here's the catch. They had a fatal flaw. They were just not very efficient. You needed these huge, heavy, and frankly dangerous boilers. And a ton of the heat from all that burning coal was just lost to the air before it ever did any useful work. They were powerful for sure, but they were also incredibly wasteful. So the next great engine had to solve that problem.
And the solution came from a totally new kind of fuel and, honestly, a pretty radical new idea. What if? What if you could just get rid of the boiler entirely and move the fire inside the engine? And the key that unlocked this whole new way of thinking? Petroleum. Suddenly, we had this liquid fuel that was just packed with energy, way more than coal, and you could inject it directly into an engine. So this wasn't just a simple substitute for coal, it inspired a complete and total rethink of how an engine could even work.
Okay, so this right here, this is the single biggest conceptual leap in our whole story. It's night and day. With steam, your fire is outside, in a boiler, just heating up water that eventually does the work. But with internal combustion, the fire, this tiny, perfectly controlled explosion, happens inside the cylinder itself. It pushes the piston directly. No boiler, no steam, almost no wasted heat. It's just way more direct, and because of that, it's vastly more efficient.
And the man who really grabbed this internal combustion idea and perfected it for heavy industry, well, that was a brilliant German inventor by the name of Rudolf Diesel.
And in 1897, Diesel showed the world what he'd been working on, and it was an absolute game changer. He had created an engine that could harness the raw power of internal combustion with a level of efficiency and reliability that no one had ever seen before.
So what made the diesel engine so special? Well, it was everything the steam engine wasn't. It was compact, it was powerful, and it was incredibly efficient. And its real genius was how it ignited the fuel. See, instead of a spark plug, Diesel's engine used immense pressure to squeeze the air in the cylinder until it got incredibly hot. So hot that it would instantly ignite the fuel the second it was sprayed in. This compression ignition was just way more powerful. It made the engine unbelievably tough and reliable, absolutely perfect for powering massive ships across the biggest oceans.
It's kind of amazing when you think about it. That brilliant invention from way back in 1897 is still the direct ancestor of the engines that power our entire global economy today. But of course, over the last 100+ years, engineers have been very, very busy perfecting Diesel's legacy.
So what did they do? Well, first they perfected the engine cycle, creating two stroke designs that give you a power stroke with every single rotation of the crankshaft, not every other. Then they added turbochargers, which are basically like super powerful fans, cramming more air into the cylinders to make bigger, more powerful combustions. And then came the brains of the operation, modern electronics and super precise fuel injectors that optimize every single firing to squeeze every last bit of energy out of every single drop of fuel,
all while keeping emissions in check. And when you lay it all out like this, you can just see that beautiful, clear chain of innovation. You know, none of these steps was just a random discovery. Each one was a direct answer to the problems and the limitations of the one that came before it. From the inefficiency of steam to the incredible power of diesel, it's just a perfect story of problem, solution, and constant refinement that's still going on right now.
It's really a remarkable story of problem solving, isn't it? Watt's steam engine solved the problem of how to harness mechanical power in the first place. Diesel's engine solved the problem of efficiency and size. Which brings us to the big question for today. When we look ahead at massive challenges like emissions and sustainability, what problem will the next great engine need to solve?